So, hi everyone. Today, what are we going to do today? I think I will continue with bsp.nvim refactor or improvements. But first, let's start music and maybe we look today a new album or something to hear. See what Panda Beats has also. Maybe something new to hear. Okay, maybe something a little bit faster. What I already have in there. Music, chill house, and special. Get some chill house. I have chill house 3 and 4. Maybe also candy trip. Where is it now? This is the first. Let's see, chill house moments. Which one is which? So, I think this one is the first one. a second, I think. Play this music. Also add this candy trip folder. Okay. First update our tools. I also changed. Oh, there is something weird. I also simplified for you if you want to try out the BSP servers, or you can install them with bsp.nvim. So what I basically did, I think it's not here. Oh, it's here. What I did is I renamed the repository and also removed all packages from the fork that are not BSP related, just that I are not spammed from RenovateBot with new versions of these packages. So currently it's only BSP. Come back. So actually we have 4 BSP servers. The Basel or Basel, I'm not sure how to pronounce that one. This one is not ready yet, but the others you can use. They should work, and if not, please open an issue. And I have to update the configuration also for that. So basically I can remove this, use this one, and this should already. Okay. Update maybe everything with lazy. Quite some changes here. Okay. And now let's update the servers. So it looks good. Let's update the main here. I think last time I looked into the handlers. Okay, I can remove some dysfunctions. Unused. I can also remove this part neatly. Will target did change. We'll let this one uncommented because I think I will use it later on. So maybe we could look it up how to create a proper overflow window here, like this. No, not this one. LSP info. It was different before. bsp info. Working like that, but maybe more prettier. Clean up here a little bit. Oh, it was rework configuration. It was reworked. So there's no link compile native source or Lua snip. You can use link compat plugin with the comp Lua snip and comp source in the meantime. So let's see what it now looks like. configuration, the default configuration. Default list. Let's open up Alacrity. I have here key map. Okay. Highlights. So this one is somewhere else now. Appearance. Let namespace. Node font, variant, trigger, signature help. Just was wondering if I do have the new version. I guess so. Appearance. Let's move everything in there. We have here NVIM comp as default. That's the fallback highlight groups to NVIM comps highlight, useful for when your team doesn't support Blink comp. Okay, then this one. Oh, this is basically this one. This part, and we have sources, which I didn't touch. This is the same. Right. Yes. Setting capabilities for NVIM LSP config. I think I have it already. Yeah. And here, snippets, function to use when expanding ASP provides snippets. This is the default. So I have completion, and in there we have the triggers. And accept. Triggers. Okay. Completion. This part. Brackets and signature help. If this is this signature help is disabled or something now, is it not available? Menu. Oh, there is signature. Fuzzy. This is here on that level, which is completion level. So like that, right? Then we have also this window. Documentation auto show. Documentation. And this would be then here. Is that the window? It would be here. I'm not mistaken. Is it actually inside? No, it's not inside the menu. Okay, then let's see if this works. Maybe I have to open up that project. So let's write some tests to see if the configuration behaves now as expected. Examples. Let's have protocol tests here. Can we test? You could test for diagnostic messages, right? If we get the correct diagnostics, just pretend we have here name example 2, right? And rename it and call it just with errors. No. What we will do here is introduce a bug so that this one would get an error. Maybe a better one. We do it there. Here. This would be row 19, column 16. Copy this part. Actually, I need to copy this one. Should I? This bit initialized. So maybe I have to switch here. What I was thinking currently is that I want to change the projects here. So maybe I have to do it for every test here so that I can switch for different tests the projects. So let's see here. I would use this other project. Request compile target. Methods. bsp methods, we'll here compile. So build target compile, it's called. Request build target compile. Then project or project with errors. Best does have. Welcome to the stream and thank you for the follow. Actually, maximize that window. Oop. Let's look up the shortcuts. Keyboard. Nope. I think it's in the settings here in Cosmic. I'm used to Sway, so I'm currently don't really know the key bindings. The tiling stuff. Where is it? It should be here, right? There it is. No tiling. So as for stacking, G for floating. So let's do this. G, yeah. Toggle orientation would be applicable here, but here, swap window. Toggle orientation would be, okay, this is this one. Stacking. Window tiling. Does this mean? Oh, okay, on off. But where is full screen stuff? Sticky windows. So stacking. Okay. I think I will just move them like this. So let's see here. We have this as bsp.net. What did I call it? With errors. With errors. With arrows. So with arrows. No, actually it's not here. This was there. Oops. The colors are looking weird here, right? So we get the workspace here. And after I get the first one, let's actually build the whole solution. So I pick the target with the display names. So we have the real sites here and targets in there. And then we will say first one, which has a display name. And this one. And this will be the solution. Target. So result. This is actually okay. It's only the selected one. Seems a little bit weird here. Okay. Yes. Then this is okay. We check for not null here, and we get the solution target. We don't need this part anymore. And we will say client compile. And we will pass the compile parameters. So compile params, new compile. Now I need new namespace. So we have targets, origin ID, arguments. So for that, I would say the targets is only this one. Okay. Need to do it that way. Yep. And was origin. Good. What? That's fine, right? Oh, okay, that's a string. It's actually a string, so that's fine here. Here we need a target. We have a build target, and we want here the target identifier. So we need the ID from it. There should be the params, then we can set the cancellation token. Right, yeah, and we get a compilation result. What is the actual result? And this one is build targets. Rename this to build targets. So result. And you can assert equal, and then see what the result has. So get the compile result, which has the origin ID. Should be the same of the request, right? Then we have the status code. Should be error. Data kind and data is not used currently. And when we on that here, then we can also fix stuff. Okay. Let's actually wait. Now we should have the origin ID and stuff. So this is the one, and we can find here our expected origin ID, right? And then we can use this here. Expected origin ID. Let's actually silence this one. Editor config only for tests. So let's restart the LSP server, and we should not get any warnings here for this stuff here. This should work actually. Reboot. It's still in there here. Wait. Just maybe think of where I have to write it differently. So ID. Let's see, editor, config, C#. It's really strange why this one is not silenced. Severity none. So maybe I have to place it at the top because it's more specific first. So this could be the case here. Let's put this one or the C# rules here. Let's see our server tests. Still there. Okay. Let's search for this one. Oh, there are two of them. And that's not true here. This is the one who should disable that. Why does this one didn't work? Exactly the same. Let's remove unnecessary expression value warning. Could also set this one maybe to false. So at first try out if it makes any difference. I put it on top here, just not because I think maybe it could be because of some issues regarding the digits here. Don't think that this is the case, but who knows. Let's have so it's not, and then we can say option value true or false. If it's true, I can set it to false here. This one to false. Just put it also at the top there because they belong together. Test this out. Okay, yeah, that solved the issue. So I had to disable both. This style config, this style option, and also disable this warning. Good, but I think I could just do this one without the other, but cannot harm to disable both. So it's for the tests only, the test files only, so it's fine. You don't need this optimization here. Yeah, compiling. Let's test. So looks good here. And then we have also status code, which should be error, right? So this one fails. Returns okay. Let's see in the specs how this should behave. Not sure if this should return okay or not okay. Because I was a little bit confused about response types, because when I do trigger a compile here, it's also triggers a task run with task start and task finish and stuff. And also you get task progress. And on finish you get also the task result, compile task result here. No, that's the start. This is a finish, compile report. So you get the information here, errors, warnings, and you get also the information here, status codes. So the compile build target request is sent from the client to the server to compile the given list of build targets. The server communicates during the initial SN check whether this method is supported or not. This method can, for example, be used by a language server before text document rename to ensure that all workspace sources type check correctly and are up to date. Okay. Well, then I would expect that it should return an error if we have errors in there. Then let's change implementation, compile target build handler. Would be then here an and instead of an or. Text formatting and okay, this can be simplified. That's not what I wanted. No, this is okay. So in the build restore here, also and because the restore should work and also the build after that. Right. Oh, and then I'm gonna test again. Yeah, let's fix it. So I think we can commit this part for now. Test build target compile ensure error that if it fails it restore phase. Actually, let's build things. But also check if this would fail on restore. Yeah, this could be made simpler, I think. For now. Okay. Test project. 3. Test project path. Is this an X unit? Fact parameter. It's a theory then, I guess. But data, inline data. Okay. But, this one is in line data. Constant expression. Fake theory. Be constant. There is another way. I think in next unit. In plus parameters. So I could also rewrite upper function. I could do this kind of stuff where I do the initialization of these parameters in a class, but I think that's ugly for that use case that I have currently. It's fine if you have a more complex data, but yeah, for my current approach, it's maybe too much. So other thing would be we have here public static function that returns the test project. Test project path. Good. And then I could just define the projects here. It's constants. Let's call this one maybe class test project. So something like that. You can now do this. Could be also this could so an enumerator, but sure, let's do it just like this. Get 4 and then the string name. This right here. Project name. Keep this for now. Well, let's replace it with this one project, so I don't have to. I can rewrite it later on. I just don't want to go over the old tests and change it everywhere. Just now. Can do it later. Let's rename it with build arrows. Rename this one here also. Build errors. This one also. Errors. So now I can say here This one. It's not the path, this test project name. Say test project path get test project name. Because I want to write here more of them. Build errors and maybe I should clean it up a little bit. And have smaller projects. With things in it. Can move this. Remove first. And the other one. I don't get a structure here from the solution. Yeah, solution file. This belongs to this one, so this can be removed, I guess. This can be also removed. Right. And I can remove this too. And this also. So now if I copy this and code with restore errors. This one without errors, and fix here. It was in the program CS. This, and it should be fixed here, but we need to break it elsewhere. Let's say, no, that's not the right one. Here, just introduce maybe something like this, so it should fail on restore. Without errors. Either one. Then can rename this one. And rename this one. Without errors. This one with restore errors. And then we can do the same here. So I handle both. And let's actually see if this really fails on restore. Yep. So I could say this is the error that I would expect. String error expected, error message expected, error message. And here, that's actually the wrong one. So this one be the right one. And here we can open up a new terminal, test projects. With build errors, .nvim build. Oops. Now I would say we would expect this error. This is now how this is not how the error would look like when it comes from the build server, but I will modify it later. So these are errors here which are not including any locations like a range. If you from the LSP server you get the info where the error happens, like in which position in the source file, but this is not always the case for the build tools, and this is one example of that. Because actually I could also add here the like the ranges that I would expect, but I think for now it's okay. Now we have to figure out how to read the diagnostics which are on the spec are provided here via this tasks that I mentioned before. So we get this callback on build task start or not a callback notification. It's a notification here when this starts, when you have progress messages, and then when it's finished. And I think I did a groundwork for that already. With the server callbacks. This is for diagnostics. Which is handled separately. Let me think. So we will definitely have build tasks, notifications triggered, so we could check for them. But we also could check for this publish diagnostics. We could have a collection here. We could call a collection. Diagnostic. Collection. So in here, get a list. Test diagnostic. Make field only. Okay. And here we can return this one. Wait, what I'm doing? Diagnostics. So this can be simplified. Okay. Also nice. So we can write it here to the test output helper, but we also write it here in the diagnostic collection. Add just and range. And we add the diagnostic directly. Publish this. Put help. Okay. We can also write the log messages. Message type, task ID. Right, in a similar fashion here. All this log messages collection message params and kinds log messages collection. I need this collection, oh, not really, right? So I will keep it shorter. Here we also do the log message collection, add and log message parameters like this, and we also have to change this one. Yeah, I'm sure this cannot work. And then we have this all the other things here that we can also implement now. Copy this. Task start. So let's build task start. Task start parameters. So this would be build task params. Task. Oh, this was task start balance. So this is the right one. So we remove this part. And we could also do the same here and write them down. But I think if we can, I would like to have them all in one collection, so that I get the order right. Also, when I can check for the order how the messages are coming in. Like if build task start was before the end, and if progress messages were received after the task finish notification. Notifications. Task notifications collection. Task notification. It would be notification, right? Because it is a collection. Here, task notifications. So and then I would try to task notifications collection, add task start parameters. Don't have an idea how to get them together, because these are different types and different classes which do not have any common interface or something. But yeah, anyway, I guess we will figure it out. So let's create the other couple of task progress and task progress parameters. And also, yeah, and this one to write task progress message. Let's maybe format the message first. Message string format. We'll have here the Sherich. Do I pronounce it right, Sherich? Yeah, welcome back first. And no, I don't use Universal Blue. I used it before. Yeah, that's the blue images. No, I used it before, but then I switched because there is currently an unofficial image which contains Cosmic, but from one of the Fedora atomic maintainers. Let me see if I can find it. GitLab. No, atomic. Cosmic. Yeah, it's hard to find here, but actually, if you look in this repository, this is from one of the maintainers, Timothy Ravier. He do a lot of stuff for the atomic desktops, so and he has here in this repository also this Cosmic Atomic. They build it, I think, daily and then push it also to here. Let me just organization. Yeah, there is this Cosmic Atomic. But as they write it here, this is unofficial and it's experimental. So this is the one I use currently. I think with changes also. Let me just see. I'm not sure. Yeah, this is the one that I use. On that registry. And then I have a couple of overrides on layered packages like Alacrity and yeah, some Sway stuff that I currently not use, but I could start Sway. But yeah. The idea was maybe to play around a little bit with Sway and Cosmic components, but yeah, didn't get to it yet. Okay, what's wrong with the music? So, music just died. Okay, let's try again. Maybe it was because I started Cosmic or something. I mean Sway, not Cosmic. Yeah, I rebased multiple times. I rebased firstly from Silver Blue to U Blue, Universal U Blue, the Cosmic variant from them. And then I used that for a while, and then I rebased to this unofficial Cosmic Fedora image. Let's just, yeah, here you see it. I was using this uBlue as Cosmic 40, then I switched to this one. And there before I was using the Silver Blue official images. Are you considering to try it out, or? Just rebased. Oh, I'm not sure which version I have, to be honest. $11.25. What do you mean by that? So, yeah, this was the update, yeah. But this was not a rebase, this was just a regular update, because as you see here, this is the same image, but a different digest, so it kind of the same tag, but different image behind that, so this is just a regular update. If I do RPM OS 3 update, that's what you get. But this was a rebase. This two, from this one to this one. no, you don't need to rebase to update to a newer version. Rebase is just if you switch from one like image source to another. You can imagine this like an image source, like a repository that you choose. Yeah, kind of. They are immutable. That's why you get the digest here. But yeah, you can imagine this one. It's more like a repository definition. Like if you say you track the how does it called? Let me see. Md sudo dnf. Oh no, how is it called there? Repo list. So this is this one. Yeah, it's got another one here. So this is kind of similar. Let me just rerun it. If you would say you track the Fedora repository, this is kind of the same, but here there are multiple packages provided. Here you get the whole OS as one image. I'm not sure how to describe that. That's to describe. See, like a subscription, you subscribe to that specific type of image, and behind that there could be different versions, but yeah, they pull like new versions to that, like to that subscription, you could name it, I think. So these are basically Docker containers. So what you have here is, this is the repository name, and then you have a label behind it, and the label behaves pretty the same as a git tag behaves. So if you push new images to this repository, you can retag this new image to be the 41 with the 41 label. So like in git tag, this would be like a new tag which now points to the newer version of your host image or OS image. So so you can't change anything there. Yes, I cannot change anything in this image, but what I can do is change on top of it. So I can say I don't want a specific package inside here. I can override it. It is not removed, but it's kind of hidden for me for now. But this is basically how containers work like Docker containers. They have layers, and if you build a Docker container and you remove something in the next layer, it is still in the previous layer, but in the next layer it's hidden. So, and if you download like the whole container image, then you can have multiple layers of this image or inside this image, and you can have files in that image that are there but not visible if you use the image, because they are kind of hidden in the higher levels. It's higher layers. It's a little bit hard to understand, I think. But it is how it is. Yeah, maybe it's easier. Yeah, but it has drawbacks, but what it's good for is that you cannot change the previous layer. I mean, you can change it. You can kind of hide stuff which isn't before in the layer before, but it's not gone. You can see it. If you inspect the image, then you can see the files that are in the previous layers. That's why I think they come with this immutable stuff. Maybe it's one of the reasons, but yeah, it's not like really immutable. That's why they renamed it now to atomic. I can still change stuff, but it's like I cannot change the image itself, but I can change how it's used on my system. It makes sense. And this layered packages is exactly that, what I meant. In the higher layer you can add stuff or remove stuff from previous layers. So if I have in the base image here from Fedora something that I don't like on my system, I can remove it in a higher layer, and it's then not available for me when I use the system, but it's still in the image, in the base image, in the previous layer. Yeah, I added them manually. You can use here the OS3 install command, and it creates for you this kind of layered this layers with the new installed packages. Yeah, the base is provided from Fedora team, and it's always the same. So if you now pull the same image, then you have the same hash here because it's the same image. And then on top of that, if you can add your changes, but this will not change the image itself. It's just adds these changes on top of it, if it makes sense. That's why you can always revert also to the previous state, because it's not changed in the image itself, it's changed on top of that. There are many details around that, many of which I also not understand in like that deep, but this is like the basic concept. And then your two last images are separated from each other. Yeah, they're completely separated from each other, yeah. From the concept, you can imagine it's a little bit like Git. If you really look at a higher level, if I switch or rebase to this one, this is like a checkout in Git. So you really change like the parent, and yeah, if I roll back, it is like a checkout of another branch, which could be completely different. Like if you have two branches and you branch them early on, then they could evolve completely different. So, and if you switch from one branch to the other, it change like everything beneath, or like everything for your file system. So this is kind of the same concept. So if you switch from this one to this one, this could mean there are many changes between those two images. That's not rebase, no. Rebasing means you switch to a different source here. So if this one and this one is the same, then there was no rebase. And if you have this one and this one, they're different, then you know there was a rebase here. So technically, if I update here and upstream, they would push a completely different image to this repository and with this tag, then it would be the same as a rebase, because underneath you change a whole system if you update. But this is not what they defined as rebase. This is, and they don't do stuff like that. This is just from the technical point of view. But yeah, that's kind of a convention. Just rebasing means you switch to another repository and tag. Also, I've seen that Fedora on the official blog post have announced about switch from rpm-ostree to bootc. Yeah, that's what I also was looking into. I don't get everything. Also, how this, like the differences and stuff. But as I understood that bootc is kind of a split of OS tree in two different parts, which means the boot C is taking care of this part here, getting the, or like registering which repository do you track and with which label. So this is your source of updates. And this layering stuff, so if you want to remove something which is in the base image, or you want to add stuff that is not in the base image, then you have to use a different tool. Boot C cannot do that. RPM OS3 can. So you can update, you can rebase with RPM OS3, and you can layer new packages or remove packages, or like create new layers with removed packages from your base image. But they want to split this. So I think the use case for boot C, if I'm not wrong, is more like to have it also, they want to use it also with core, not CoreOS, how was this called? Let me see, Fedora. They have here different variants. So CoreOS, and I think maybe for the cloud, but mainly for the CoreOS. It's like for use cases where you don't want to layer stuff. It's just like if you have devices where you want to provide updates for like IoT devices or something, then you would do that with boot C. You can provision your IoT devices with this configuration that it tracks your repository with a specific tag, and then that it does updates on a regular basis. And when it does it, then it pulls always like the image from that source, the newest one, and updates the system. And it can do it in a fashion, if it cannot boot, then it goes back to the previous version. You don't have to layer in that scenario any like specific packages, because you would build your base image already that it includes everything that the IoT device needs. And if you need to add something or remove something, you just distribute it via this base image. You just build a new image with the same repository and tag without something that you want to remove, and then you push it and the devices pull it in this in a specific schedule that you want to configure. Yes. And the cool thing about this is that the image is immutable and is hashed also. So this is a nice feature. If you distribute this one, you know this is like an image for the whole system. There are just small parts that are running on the system which do not change between these updates, but the most part is really this image. And if you switch from this this image, from this this image to this image, then like most of the system could be changed in this switch. Yeah, there are some with NVIDIA drivers included also. Actually, I also wanted to try this one out for my private Kubernetes cluster. I think IoT is one of the use cases, and also this CoreOS. And this would be nice if you have like some device like a Raspberry Pi and you configure it with boot C and any atomic variant or CoreOS variant, and you set it up that it has to do like updates daily or something. Then you have just one Docker repository, which is also easy to do with GitHub and stuff, also for free if you want. And you then can always update your devices when you provide a new container image and push it to your registry. And the devices pull this image, and on the next reboot, or like on the next update, you can configure it that it has to reboot, and then you have the new version. It's kind of nice and round process to update devices. Yeah, there's also server variant. I'm not sure if they're using boot C for the server variant. Not sure about this one. But it would also make sense to do that there. Yeah. Data center to Raspberry Pi. Home labs and stuff. This makes the whole process pretty easy to distribute host images or updates for your host system. Because the Docker container registry is easy to set up and also like to get one. And to build Docker images is pretty easy because you have nice tooling for that already. And now with boot C, you have also a nice tool for the host side, or like for the device, which should pull the updates. That's a nice all-round solution. No, it's not inside Docker. It just uses the Docker container as a transport layer, or like transport vehicle, or I don't know how to describe that. You can imagine Docker container are like bigger zip files, actually, with layers and some logic around that, which enforces this that this layer didn't change. So you have meta information to the zip, and which describes which layers it has and which hashes they have and stuff like that. I think it's in the meta information. I'm not sure, to be honest. But this is like a zip, and then inside the zip you have the definition of these layers and stuff, and tools around how to work with this specific format of the zips. But we can also just look into one. It's also an interesting. I think I don't have it installed. Let's pick some small image, something easy, Docker, busy box, something. busy box. So to your question, it's not inside Docker container. You just use Docker container to transfer the files, which then are extracted on your host, and they are extracted in a way to your system that allows you to switch between those different images in an atomic way. So let me just again rpm tree. So these three images are on my system. If I want to switch between them, it's in an atomic way. And when they are downloaded, they are transported in this Docker container as a transport format, I would say. And if you downloaded it, then it will be extracted to your host system, and then the tooling is responsible to kind of switch between the structures. So when it's on your system, it behaves more like Git. It has also something like .git folder where all the references and objects are stored, and if you do a git checkout and do a git checkout of a specific branch, let's say I would switch to this one back, revert, change to this one, then it behaves more like git checkout on your system. But if you try to pull new updates, it behaves for the update process more like and it behaves not like Docker containers, but it's transported in a Docker container, the whole system image to which you update. I can only show a little bit of that because I'm not that deep in the whole details. I just know the raw concept. Let me see. We have here OS tree. We have boot. So basically this /OS tree is comparable to .git folder. And your head ref, which you have in Git, is just a pointer to a specific version in your Git history. And kind of similar is this one. This soft link is pointing. This is the current booted version. And this is, or like not current booted, this is the current selected master, which when I restart would boot. And this one points to this folder here. And if you look into it, OS3 boot 1 Fedora, then you see there are 3 folders which has a cryptic name. And if you look into them, you see this is kind of like the objects in Git. You have different like snapshots. How should I describe that? These are the images which you saw before. So this 3 are these 3 folders. And if you switch from one to the other here, then it switched the soft link here between them. And not exactly this one, but it's in the boot process. It's more, let me see if I can show it. You have here this loader. Entries. Now we can cut. So you see here, you have references to these folders, what I showed you before. And if you boot, it just points to the specific folder. So if I switch that I want to boot with this image, then it changes the entry here for the bootloader, and then it shows here for the next boot, it switches that to this one. And if it's boot, when the system boots, it sets it up that it used this folder. And if I look in this folder here, then I see the files that are inside this image. So it's extracted from the Docker container into this folder here, and everything which is inside of that container is now here as a file structure. So there is no Docker container stuff here when it's extracted, just for transport. Yeah, Fedora Atomic is improving and improving fast, I think, on open source project. But yeah, I think they are working on this kind of concept and improving it for years, so it's not new. But the newer changes, what they make, they put also kernel. I think kernel images also into the container. So this one would be then deployed also inside the container, or with the container, when I understood that correctly. So, and then if you switch between those deployments, they are called deployments as it seems, then you could also switch the kernel and stuff. And what's also nice is if you boot one of these images, most of the system files are mounted read-only. And only a couple of folders are read-write mounted. So your home directory and like what was that, temp folder, var user or something. Yeah, just a couple of them, and the rest is, therefore it was called immutable, because you cannot change anything on the system, like on the core system at runtime. So as long as it runs, you cannot change it. It's read only. And then you have to use this tool to pull a new version. It's then extracted to a specific place, and then if you reboot, it's reboots in this new system and then mounts it also read only. You cannot switch kernels on the same image. You have to build a new one with this new approach, when I understand it correctly. So this is also one thing that I'm not that deep in that, because I didn't developed anything of that, or also not looked at the source code yet. So this as I understood that they distribute the kernel images also then with the container, and if you want to have another kernel image, you have to build a new system image and pull it then. Or you can also layer on top of, I think it would be also possible. And also one thing that they want to distribute is the bootloader, I think, or the boot shim. bootstream also with inside the post image. As I understood it, they try to move as much as possible into the image so that you basically have less and less stuff that is outside of this image. So if you switch between images, you have only a small piece that is running on, or like this is, which is not inside of the images, but the code that needs to be there to be able to switch between these different deployments. So maybe I should take time and also dive deeper into this topic, because it's really interesting also. I think it's better than NixOS in terms of security. Not sure about that. As I said, I'm not that deep in that one, and also I'm not sure how NixOS handles that, so cannot compare really. Yeah, the learn curve is less, I would say, than NixOS. Even if I don't really know NixOS, because I think the differences between a regular system and an atomic system are not that much from, like, not that different. Yeah. But you can also play around with that if you have a VM, or if you have like a second machine, then it's easy to play around and create custom images because what they now also support is creating those images from Docker files or container files. So if you, let's say, if you would like to create a new distribution which is based on Fedora, like uBlue does, it's basically only let me show you. It's basically, I think I showed it before already. I don't have it here, but let's say you want to create a new one. You write container file, or you can call it also Docker file. Maybe for the most people, the Docker file is more familiar than container file. But anyways, you write a container file, and then you write from, and then let's just open up a new terminal. Let's -rp-g. Let's grab this one. Right. And then let's say you want to install, you just want to have Fedora Cosmic Atomic with Sway inside it, and I'm not sure, remove some other packages, then you can just say here run sudo DNF. I'm not sure if they already put in DNF 5 in here, but we can try it out. Install, let's say Sway, and you want to uninstall, I think it was uninstall, I'm not sure how the command was. Let's do this and have uninstall Firefox, right? And I can split here. I split here, and then terminal, and then you can podman build at least your system is read-only and the most of your software running inside of container. Yeah, if you use the toolbox, then most of the stuff is running in container in the toolbox. But yeah, I mean, I'm not sure if you can say it's more secure, because if the tools can update what your next image should look like, then I think you as a hacker could do it also. The only thing is that as long as it runs, it's read-only. But if you reboot, so if you get some virus or something, and it knows this is an atomic system, it could manipulate stuff, and then the next reboot it will be mounted read-only, but it still could mount stuff which contains some malicious stuff, and then just extract parts of it into that space which is read-write, like temp folder or something, and then do stuff. I think it depends, but it's still more secure, I think, than a regular system, because most of the stuff is read-only at runtime. But I'm also not a security expert, so. What I think is really good for is that it's for regular users. If you update and the system breaks with the new update, you can always roll back. There are just really small edge cases where it can happen that you cannot roll back or make your system unbootable with that approach. Because on a regular system, if you update some package or you install and deinstall packages, then your system can be in a state where there are leftovers between between the install and uninstalled stuff. So, and if you have like some image which is maybe having some bug or something, and you install it and it installs stuff and manipulates something on your system, and you deinstall it, it's still like the manipulation is still there of the system, and it can cause issues and stuff. And with that approach, you get always this, like the base image. This is where you start from. And if you have some stuff layered on top of it, and you boot into this new version, then as you saw, it switches to the new folder structure, and everything from there, how do you say it? It's now active, so you don't have the leftovers from before, because this is like a new folder, and everything which is inside your base image is newly extracted to this folder, so you don't have any leftovers if you install and deinstall. And also, if you layer on top and remove packages, layered packages, it is always the process that you take your base image, and then even if you remove stuff, all your layered packages are done, like are installed on top of this base image. So if I remove something, then they take this base image, and then they create all the layered packages that I installed before are completely new. So you don't have any leftovers, because it's always done from base image, and then all the steps again, always if you change anything on your layers, or like on this layered configuration that I showed before. So if you are here, let's say here, and if I remove here this blue man, then it takes this image, and then it installs everything, all this image, all the packages that are listed here on top of this base image again. And then you have new version base image plus installed packages which are layered as your new version which you can boot into. How was this called? It has a name. Was it this OS tree concept? So basically they described this concept here in OS tree, how it works. Here they also described like Git for operating system binaries, which I described before. And maybe it's confusing first, but RPM OS tree uses OS tree behind the scenes, as the name already includes that. But what it does differently, it's if you layer packages, it layers it with RPM. So it's that's why it's called RPM OS tree. So you could have something like DNF OS tree, also, not DNF. How is the package apt from Debian and Ubuntu. So apt OS 3, which could also layer maybe apt packages on top of OS 3 deployments or distributions. Let me see, what was this called? They describe somewhere this effect in regular Linux distributions, that if you install and deinstall stuff, you have leftovers in the system often. And if you would have two systems which you start if you install exactly the same stuff there, and you would on the one system install different packages and like 10 packages and deinstall them again, and on the other system you install only one package and deinstall it again. So at the end you should have the same system, because you at the system A you installed 10 packages and you removed all of them, and on the system B you installed one package and you removed it again. But the systems may be not the same, because on the system A you have more leftovers and you have files and configurations changed because you had this more installs and deinstalls as of system B. And this is something which cannot happen if you use the atomic system. The only thing that can be leftovers is in the /etc folder, this configuration folder that you have, because this has to be locally changeable. Yes, you could not configure your system differently, so it's yeah. It's here somewhere. By the way, do you use Flatpaks? Yes, I use Flatpaks. I think Fedora encouraged you to use Flatpaks if possible, or where possible. And also an atomic variants, kind of, yeah. This, if you can, you should use, because else you need to layer, and I think the idea is you should not layer that much, because yeah, as I said before, if you update or change something, then all these layered packages are always installed on top of the base image. And what it means is also, if you're updating your base image, so if you do a regular system update, your base image changes, and everything that you're layered on top of that needs to be reinstalled every time you update. So if you have like hundreds of packages, then it takes pretty long to update. And it also means if you update and you have some packages layered which would fail to install, then your update would also fail. You would need then to either remove this package from your layered packages to be able to update, or wait till the base image is, maybe have a fix for that or something. I just try to find the right wording for that. It has a specific name. This problem has a specific name that you have, like, if you install an RPM package, then there in these packages are usually also not only in RPM, apt and other packages that have the same thing. They have install and deinstall scripts and cleanup scripts. You know, if you ever used Windows, there's more commonly there also, if you install a game or install a program and you remove this program and you look into the folders where like commonly the programs install their stuff there, and you see still that there is something left after you uninstalled that, even if you mark it as clean everything and you don't want to keep configuration files or something, which is sometimes possible if you uninstall, just because they forgot something or they wrote something into the system in specific folder where they don't remove it from there when you uninstall. That's what I mean by leftovers. Not only config files, and also sometimes they change something on the system. Like, let's say you install one program and it change something in your registry in Windows, and you uninstall it and it didn't change it back, because in the meantime it could also be changed from another program. So it's just change it in one way and don't change it back. So after you installed one package and you uninstalled that package, your system is not in the same state as it was before you installed this specific package. So there are changes that you cannot revert, basically just because you uninstalled the package. Actually, it was invented from the GNOME project, I think. There's OS3 concept. So here, this is basically atomic upgrades and rollbacks. OS3 is designed to atomically swap operating systems, such that during an update and reboot process, you either get the full new system or the old one. There is no, please don't turn off your computer, we don't yeah, we do this by simply using symbolic links like this folder that I showed you before. So this is the atomic switch between the version that you want to boot at the end. And where the game OS, GNOME OS has the full regular file system tree with US, etc. directories as above to upgrade or roll back. There is no difference internally. We simply check out the new tree into GNOME OS, for example. This, then swap the current symbolic link, then remove the old tree. Yeah, where was, I think it was here somewhere. Endless OS use also libOS tree. But yeah, we were before here also with building our own image. It failed because of, oh, I have to use here. Yes, I think here also yes. So I didn't find that. This, I think here this should describe it. The difference between the regular package managers. Because OS tree is designed for deploying core operating systems, a comparison with traditional package managers such as DPKG and RPM is illustrative. Packages are traditionally composed of partial file system trees with metadata and scripts attached, and these are dynamically assembled on the client machine after a process of dependency resolution. In contrast, OS tree only supports recording and deploying complete bootable file system trees. It has no built-in knowledge of how a given file system tree has generated, or the origin of the individual files or dependencies descriptions of individual components. So it didn't really know about how it was composed. So put another way, OS tree only handles delivery and deployment. You will likely still want to include inside each tree metadata about the individual components that went into the tree. So this is kind of an extra feature that you can do if you want to have this information, what's inside and how which packages are inside and stuff like that. So this is metadata. For example, a system administrator may want to know what version of OpenSSL was included in your tree. You should support the equivalent of rpm-q or dpkj-l. Hard to pronounce, I'm not sure how to pronounce that. The OS3 core emphasizes replicating read-only OS trees via HTTP, and where the OS includes, if desired, an entirely separate mechanism to install applications. Stored in var if the system global or home for per user application installation. An example application mechanism is Docker IO. However, it is entirely possible to use OS3 underneath a package system where the content of user are computed on the client. For example, when installing a package, rather than changing the currently running file system, the package manager could assemble a new file system tree that layers the new package on top of base tree. That's what I described before with this layered packages, but they describe it a little bit nicer, I think. Record in that layers new packages on top of base tree. Record it in the local OS3 repository and then set it up for the next boot. So basically, a malicious program could also do the same. Erplank. Hi, welcome to the stream. Why do you thought I don't speak English? I'm not a native speaker, but I try my best. Really? French? But I think I have in the tags that that the stream is in English. Yeah, maybe I should also include it in the title. Yeah, I currently we look into the concept of OS tree because I use Fedora Atomic variant. But I was also trying to write a little bit Lua for my bsp.nvim plugin, which is a plugin for build server protocol. This is the client side for neovim to implement this client side part of talking to the build server. And yeah, on the other side, I also build a build server. I program a build server in .NET, which is there for building .NET applications. So basically what this is for is that we have on the neovim side a plugin which calls a protocol which is similar to LSP, if you know that, language server protocol, but this one is for build tools, not for programming languages. And what you can do with that is if you install a build server that supports thank you for the follow. Yay, we got the goal, 80 followers. Thank you guys. So and what you can do with that is you can more easily build stuff from inside neovim. So what you usually have, or like Vim users usually do if they want to build something, they set up this make command, and you can also parse the errors which result from the output of this command. So if you set it up to .NET build at something, you can parse the output and then you can show the errors and stuff. But I like it more that you can integrate a little bit more than just the errors. And the build server protocol is basically therefore that you can do more than just build errors. It can clean up your directory. So if you do a .NET clean, you can do the same like from inside neovim in a way that it could interact with different other build tools, not only with .NET. So that's the idea. Where the program stores the files in atomic system. I skipped this one, sorry. The program stores them. It depends what, like if you install the program, then it's also stored as a separate layer, also in where is it layered? It's layered. So it depends, because you can install, I think you can install programs and it's just layered there where the program decides that it wants to put the files in. So, but it's on an extra layer. So if you remove this program, then again it takes the same approach. It takes the base image and then reinstalls every package that you layered on. So in a regular system, if you uninstall a package, then you take the system as it is now, and then you run an uninstall script, and therefore you can have leftovers. In an atomic variant, or like in an atomic system, you take the base image and you just install everything, but excluding this image that you want to uninstall. If it's layered packages. If it's a package that already in the base image, then it's a different story. But yeah, that's how it works there. And therefore, because you always take the base image and you do the process from there on, it results always in the same state. It's like reproducible always. I got a question. Do you know how to code a random Twitch streamer generator? What's a random Twitch streamer generator? What can you do with that? Because if I don't know what it is, I cannot say if I could program it or not. I think maybe it's code remove. I'm not sure. So yeah, now I have the right commands, and now I have the image, the container image. And when I also now install, let's just try to let me open a new terminal here and switch to a toolbox. Install scripts dive. This is a cool tool, and let me see. I need maybe to get the newest version of that. Dive tool. We have already version 12. So this is the one. Let me put the link. So it's not provided as a bar anymore. No, it's can still be 5. Oh, wait, let's switch here to the newest version. So, let's try it again here. This cannot open no such file or directory. Zero 12. Zero 12 0. That's fine. It's downloading. Okay, so I have to rewrite the script first. Wait, curl should have curl minus O for output, right? So let's try it again. Something is off here. Oh, maybe. I think I never run it from this directory, so script. I need to change my script. Yeah. More output than URLs. Okay. What does this mean? Why is this? More output options than URLs. Just wanted to show that, but now this somehow didn't work. Try this one. More options than URLs. Does this even mean? I tried this. Sorry. So okay, now. Okay, let's say does this -o mean? Remote name, write output to a file named as remote file. Oh, okay, yeah, that makes sense. So it was stupid from my side. So, now I have dive installed, and I also fixed my script, which is nice. Here, let's remove this packages. Clear. Now that we built this image here, this one, what we can do now is dive into this image and look how it's built. I hope it will not crash immediately. Because I think the image is pretty big. Maybe we should have done it with a smaller image. that I can close this one. So now we have this image opened here. Maybe we can close this one to have it a little bit bigger. Yeah. So now you see that these are the different layers that you have. You see at this layer there is Firefox, ellipse and stuff was added. I think I don't see that, but the UI didn't go down. There are more components, and at that point here it's like for every package there is one layer. But it doesn't have to be that way. It can be also done differently. So basically one layer is just bunch of files which were put in a folder, and this makes the layer. And the end image is if you put everything from one layer and from the next and from the next and from the next, and then at the end you have like your end result of files that you have in the image. So and at the right side you see what files are added at that specific layer. I think it takes just long because the image is pretty big. Yeah, total size of the image is 5.6 gigabyte. So, but you don't have always to pull every layer. It pulls only the layers that are changed. So this is not the download size on each update. Let's just maybe go. So we can filter here. No, show aggregated changes. Thought it was possible. Okay, now I see it. You can here remove the filter, and then you can say I want just to see added, removed. Let's remove the unmodified files and only show the files that were changed from the previous layer to this layer. So then you see It's basically many things in the OS tree here, the OS tree folder. Let me just collapse this one. Here you can basically see then what glibc installed, and then if you go next layer, you see what Mesa drive DRI driver installed or modified on the next layer. And so you get a bunch of layers which introduce changes to the previous layer, and when you apply these changes, you get a new kind of view at the file level. Which is pretty neat, I think. And what really is cool about that is that in the way I look now at the image, you can just see what's inside your system image, and also see what changes it introduces. So if I would like to find out what the changes are between this version, what I currently booted, and the previous version, I could compare these two images and see the changes between them. I'm sure there is already a tool for that. Compare to container images. On file level. Container diff. So this sounds like a toollet you can use for that. So container diff. Yeah, from Google. Diff OCI. Okay. It's a new one, as it seems. It's not that many people are interested in this one, as it seems. So no forks are active currently. Yeah, but yeah, still you can do that. So you can just compare the images and see what the changes are. Stream. Just cannot find this description that I meant for. Yeah. I think I will not find it today. Okay. Yeah. Go back. Actually, here. Yep. Then I will close this. And we will try to move on here. What do we want it here? Task progress, message. You could also serialize this one, right? Just write the message and that it's from task progress. And this one, let's write that this is a task start. Also write the message. The message. Wait, like this. And we add the last one here. Build finish, task finish with task finish params, task finish parameters, task finish, this task finish, like this, and here task finish. So the only thing is that I cannot put them in the same collection because they don't have any common interface. I could introduce one. This is pretty bad way to do that, but I will do it. I will still do it like this, just for now. Yeah. Then I will check which type it is on the other side when I try to assert which notification should have been happened. So this, close this. Here we go to our build server tests, and now we want to test which errors we got. We have the server callbacks here. Let's move it actually to rename it first. Okay, didn't rename anything. read-only field. So now I can access that no callbacks and read our log messages and also the diagnostics. And let's just count them and say, let's say we expect there to be only one error, right? So my co-programmer is here. Oh, I think she leaves me again. Okay. Here we have equal. Contains. What does the collection does here? Okay. Let's do this with equal, and let's say we think there should be one, right? Check for, do not use sorry to check for, use third single instead. For collection size, third single. What does that mean? Oh, okay. But let's say if this is 2, I still not use equal. Yeah, okay, but this makes no sense to me. And let's say server callbacks, diagnostics. I take the first one. And it's now we can assert if we have that message in there. So contains this expected error message inside diagnostic message. Try it out. Oh, that's the wrong terminal. That's still the wrong terminal. Create a new one. This project path does not have a definition. Okay. Let's restart the LSB server. I think that has something in there. Okay. I forgot to rename something here on the callbacks. All overloads and overrides of the method must share a common value. Oh yeah, sure. Now I get it. This is called always the same, so so now this should work. So it failed because we got here unable to find the package. Substring not found, and we wait, which is what here failed? String unable to find package. Not found, error, unable to find package. Okay, so this one is wrong. So this would be the right thing. Okay, now we fixed one of them, and the second one is now expected to actual one. So here it had two messages. Yeah, I think we had also here how many messages we expect that message is expected error count or expected diagnostic count should be an int. Here expected, let's call it diagnostic message, because I will reuse this maybe also for other things. So expected diagnostics count. Top. We expect only one. Oops. So maybe I will need in the future another structure for the specific in data per test. But for now, let's just use this. Okay. So now they should pass. Yeah, that's it. This part I would not say. This is the act part. This is the third part. Okay. I think that's it for today. See you in the next stream. Thanks for watching. Bye.